Hey, good morning. Happy New Year, and welcome back to the last month of physics. This is Mr. Chestnut reaching out to you, letting you know that it's a new year, and I'm excited to get things continue moving forward. Even though we're fully remote, eventually we'll be back again. It makes things easier. Up to this point, we talked about different types of concepts related to energy. And what I'm going to do right now is I'm going to do a quick review for you with what we talked about. If we look at what we talked about in the unit, the first thing we talked about was work is equal to force times distance. If we do force in newtons times distance in meters, we get Newton meters, which is the joule. So whenever you push on an object with a force and move it a distance, it will have work done to it, and we're going to see that it will gain energy. If I were to take and lift an object upward from the ground, and I take and lift this object that has mass right there uh, up to a certain height, it also gains energy. It's going to gain gravitational potential energy, which we talked about before we left, which is equal to calculated using mg, which is g is acceleration due to gravity 9.8 times h, and that will give us the amount of energy an object gains as it's lifted a height. So anyhow, those are the types of energy we talked about first. The next type of energy we're going to talk about is going to be called kinetic energy. Kinetic energy is known as the energy of motion. Um, any object that has mass and is moving will have kinetic energy. Kinetic energy is measured in joules, just like any other form of energy. It's calculated by doing kinetic energy, Ke, is equal to 1/2 of m, the mass of the object, times its velocity squared. So we'll go ahead and bring that equation with us here. Let me see if I can. No, I'm not going to be able to. I'll just write it as I need it. Go ahead and do this right here. Okay, so we'll look at our first question that we see right there. So we're going to see that as an object falls, Ke always. Let's think about this. If an object is falling downward and it has a velocity, it's going to get faster and faster and faster and faster. If kinetic energy is equal to 1/2 mv squared, as it falls downward, it's going to get faster and faster and faster, so the velocity will increase. Because the velocity is increasing, we're going to see that there will be an increase in kinetic energy. So the correct response will be B. Kinetic energy will increase. The reason why it increases is because as it falls, it moves faster and faster, therefore increasing the velocity, therefore increasing the kinetic energy. So as a ball falls from the top of a building to the ground below, how does the kinetic energy compare to the potential energy at the top of the building? So let's take a quick moment and we're going to go ahead and we're going to draw this. Here's my building here. As I lift the object up, it's going to gain potential energy. Imagine if I were to take the object and drop it off the side of the building right there, right at the top of the building. It's going to have a lot of height, but not very much velocity. If it has a lot of height, it's going to have a lot of gravitational potential energy. But if it doesn't have a lot of velocity, it's going to have a little bit of kinetic energy. So therefore, the correct response, and I don't like how they wrote it, they say kinetic energy is less than potential energy. I prefer to think about it as potential energy is greater than kinetic energy up at the top. Moving forward, we're going to do our first word problem here. It says, what is the kinetic energy of a 12 kilogram object? That's going to be our mass. With a velocity of 10 meters per second, that's our velocity. The kinetic energy. is equal to 0.5, which is the 1/2, times m times v squared. Notice I put 0.5 in instead of 1/2. It just works out easier right now with that. So it's going to be 0.5 times 12 times 10 squared. So half of 12 is 6 times 100, which is 10 squared, is going to be 600. And the SI unit for measuring kinetic energy, once again, is joules. We're going to move forward. And we're going to go ahead and look at the next problem. So we'll do another problem just like that right there. We know the object has a mass of 20 kilograms, a velocity of 5 meters per second. Kinetic energy is equal to 1/2 mv squared, or 0.5. So that's 0.5 times the mass, which is 20, times 5 squared. So this is going to be 10. 0.5 times 20 is 10. 10 times 25 will be 250. And the SI unit for kinetic energy, once again, is going to be joules. Continuing to move forward. Now we're going to look at the mass right there. If I'm just going to give you this formula in a moment right here. It says, what is the mass? If we know that the object has a kinetic energy of 2,400 joules, and we know the velocity is 6 meters per second. So the way this is going to work is that the mass is going to be equal to 2 times the kinetic energy divided by v squared. I solved that equation, kinetic energy is equal to 1/2 mv squared, for m. If we're looking for m, that's the formula that we need to use. So let's go ahead and try and plug some of the stuff in right now. The mass is equal to 2 times the kinetic energy, which is 2,400, divided by how fast it's going, which is 6 squared. Now, I'm sorry, but I have to grab my calculator. Give me one moment. And we'll do this math right now. We need to turn the light on too. And we're going to see that it's going to be 4,800, which is 2 times 2,400, divided by 36. The answer I get is about 133.3. I guess they're going for the closest answer, which is about 130 kilograms. So the SI unit for mass is kilograms. So let's go ahead and do another one of these problems right now real fast here. It says, what is the mass of the object when we know that the kinetic energy is equal to 2,000 and the velocity is equal to 10? We said that the mass is equal to 2 times the kinetic energy divided by the velocity squared, which is going to be 2 times 2,000 divided by, that's going to be 2 times the kinetic energy, which is 2,000, divided by the speed squared, or the velocity squared. It's going to be 4,000. 4,000 divided by 100 is going to be 40, and that's going to be kilograms. All right, let's continue to move forward. I think we have one more type of example to move through, which is going to be to look for the velocity. And that's what we're going to be doing right here. So we start with a mass, and it has a kinetic energy, and we're going to be looking for the velocity. The velocity will be equal to the square root of 2 times the kinetic energy divided by the mass. Everything is in the square root right there. So let's go ahead and plug this stuff in. I take my square root of 2 times 45 divided, that's a 45, even that's not a good one, divided by 3. So let's go ahead and do, that'll be 90 over 3, which is 30. So I'm left with the square root of 30. Let's see what the square root of 30 is. It's about 5.5 meters per second. Let's go ahead and I believe there's probably one more problem, and then I want to stop. Yep, which is the same thing right there. Now we know the mass. We know the kinetic energy. Let's go ahead and look for the velocity. The velocity is equal to the square root of 2 times the kinetic energy divided by the mass, which is equal to the square root of 2 times 100 divided by the mass, which is 10. So this will be the square root of 20. Let me do that in my calculator real fast, and I get about 4.5 meters per second. All right, so just to reiterate, we know that the kinetic energy of an object is associated with motion. It's calculated by doing 1/2 of mv squared. Okay, it's measured in joules. Okay, if I want to solve it for mass, that's going to be equal to 2 times the kinetic energy divided by the velocity squared. It's important to remember that mass is measured in kilograms. If I want to do the velocity, that's equal to the square root of 2 times the kinetic energy over the mass. It's important to remember that velocity is measured in meters per second. Tomorrow we're going to start to think about what happens when we fall, like we talked about earlier in the lesson. If we fall, we're going to see that we're going to be losing height, but gaining velocity, which means that I'm going to be losing potential energy and gaining kinetic. And it works the same vice versa. But let's not get ahead of ourselves. Let's focus on the practice problems that are going to be posted with this on Teams. So there will be an assignment along with this on Teams. It's due today. If you have any questions or concerns, you can reach out to me. I'll be available through Teams the entire day. Thank you. Goodbye.